Alright, welcome back. So in this video, I have another problem where we need to use polar coordinates to evaluate the double integral. We're told that the region R, which we are integrating over, lies inside the circle with radius 1 and is also constrained by this inequality here where y is bigger than or equal to x. I suggest you pause the video, try and solve the problem yourself, then come back and check your answer. Okay, hopefully that wasn't too bad. So as usual, I would like to start by sketching the region. We have the equation of a circle of radius 1 and we have this inequality where y is bigger than or equal to x. If we sketch this on its own, it's going to look something like this. So we're going to have a straight line with slope equals to 1. This is the line y is equal to x. And we're trying to figure out or find the region where y is bigger than or equal to x. If you pick any point below this line, like somewhere here, you're going to find that the x-coordinate is bigger than the y-coordinate. However, if you pick any point up there, you're going to find that y is bigger than x. The y-coordinate of the point is bigger than the x-coordinate of the point. So the region becomes everything above this line, including the line as well. Okay, so now if we sketch both regions, and we have the line y is equal to x, and we said that the region we're looking for is everything above this line, and we have to lie inside the circle, so this becomes our region of integration. Okay, and now since we know the region of integration, we can convert to polar coordinates, figure out the limits of integration, and then evaluate. So now we can set up the double integral. We have y, which becomes r sine theta. We have the square root of x squared plus y squared, which is equal to the square root of r squared, and this becomes r. And finally, the differential area in polar coordinates becomes r dr d theta. Now we need to figure out the limits of integration. So for r, we start at the origin, and we go radially outwards, and you see the region is defined at the origin, and that we always exit the region through this circle which has a radius of 1. And to figure out the limits of theta, we start at the positive x-axis and we go counterclockwise. So you see when theta equals to 0, the region is not defined, and we keep going counterclockwise until we reach the region at this line. So this line is y is equal to x, and this angle here is 45 degrees, or pi over 4. So the lower limit would be pi over 4. And to figure out the upper limit, we need to figure out this angle from the positive x-axis. So we start at the positive x-axis and we go counterclockwise. So we end up here. Since this angle here is pi over 4, this means that this angle between the negative x-axis and the line y is equal to x is also pi over 4. We also know that the negative x-axis has theta is equal to pi. So this means that this angle from the positive x-axis all the way to this line is equal to pi plus pi over 4. So pi over 4 plus pi, this gives us 5 pi over 4. So the upper limit of theta is 5 pi over 4. Okay, so now we have the limits, we have the function, we can integrate. So I'm gonna rewrite this from 0 to 1, pi over 4 to 5 pi over 4. Here we have r and another r. We have r cubed sine theta. We can go dr d theta. Okay, so if we integrate this with respect to r, we have r to the power 4 divided by 4 sine theta. Evaluate this from r equals to 0 to r equals to 1, and you get sine theta over 4. Now we integrate sine theta divided by 4 d theta, and theta ranges between pi over 4 and 5 pi over 4. So if we integrate this, we get negative 1 over 4 cosine theta, theta ranging between pi over 4 and 5 pi over 4. So if I take negative 1 over 4 as a common factor, I end up with cosine theta ranging between pi over 4 and 5 pi over 4. So cosine 5 pi over 4 is negative root 2 over 2 minus cosine pi over 4, which is root 2 over 2. So we end up with negative 1 over 4 multiplied by 2 root 2 divided by 2. And we've got a negative sign. So the negatives cancel. Let me rewrite this. The negatives cancel. This 2 cancels with this 2, and we end up with root 2 divided by 4 as our final answer.